Okay, Assalamualaikum and salam sejahtera. Today I'm going to give you a lecture, okay, for our third topic, okay, in the software development course, which is about the memory and object manipulation. Okay, so we will talk about the virtual and physical memories, and then about the organization of the virtual memory itself. Okay, and then what is the heap memory, and then we will discuss the pointers against the reference, what the difference, okay, and also what the similarities, and then the comparison between the vector and array. Okay, so array is no, typically in C, why in C++ we use vector. Okay, and then we will touch on the function overload. Okay, and then also the function pointers. Okay, what are the advantages of using pointers? Okay, and also about the file input output or IO in the C++. And now I will explain what is the virtual and physical memory. Okay, actually, to understand that each of your program that you run, okay, it contains like ID. Okay, in ID is it contains like the data of instruction, and many more information about the program itself. Okay, I can give analogy, like for instance, you as a student, your ID. Okay, let's say your ID is FB, I don't know, 12005. That's your ID. Okay, and then it contains your name, it contains your program, it contains your address, it contains your telephone number, and so on. Okay, that's the analogy. This analogous to the information or process ID of each program that you run. Okay, so how the operating system organize this. Okay, it organized in certain ways. Okay, from the range of 000 until this 0, the FFF. Okay, depending on the bit of your operating system. This is for 64-bit. Okay, you can use so basically the operating system will use within this range, okay, of values, okay, from 000 into this I think 8 times 8 for 64-bit. For 32-bit, maybe a bit shorter in terms of values for the memory. Okay, so it will organize this. This is a first data. This is okay, and then this is about the memory. Okay, this is about another information of yours, of your program. Okay, but why you need a virtual memory in the first place is because that sometimes, okay, the physical memory is basically the RAM. Okay, the RAM that you install, that exist or that are present in your computer, they are limited. Okay, so to overcome that, okay, and that's why virtual memory is needed. Basically, virtual memory is basically using the sizes of your hard drive. Okay, so it makes the running of your program much slower lah, because not because of this, copy and paste data into the hard drive. This is slower. Okay, compared to the basically when you use to copy and the data into the RAM. Okay, but in terms of the organization of how to optimize using the RAM, the virtual memory is needed. Okay, so this is basically again how the information of your process of, let's say this is one process that have the ID 10267. Okay, but when actually the program start to run, okay, the Windows memory manager will map, okay, this information, these addresses, okay, into the real, basically the real address in the RAM. Okay, let's say if no in the virtual memory it use this the address, I don't know, like 111 whatever, or BD address, but when it map into the actual physical RAM memory, okay, the address will be different. Okay, so the process may two processes may have the same addresses, okay, in terms of how each data is being saved in the memory, okay, in the virtual memory, but when it's really mapped into the physical memory or RAM, it will have a different memory. Okay, so basically, let's say that you have your own house, okay, your own house with space, okay, you can organize, okay, your table here and your other thing here, and then the other person, okay, may may basically organize in the same manner, okay, but when we want to use, okay, the real address, it will map whenever available. Okay, the Windows Memory Manager will decide, okay, where is to save the memory for your program. Okay, that's why it's different. It may contain, what you see here, each occupies different, okay, the physical addresses, although they have a similar virtual memory address. I hope you understand. Okay, to demonstrate to you, okay, basically how the virtual memory works, to show you that when you have two programs, okay, that run simultaneously, okay, it will shows you the exactly same address, okay, for the variables, addresses, okay. In this case, okay, I run the code, okay, this basically this code here, okay, using code block, okay. I hope you can install the code block in yourself, okay. Maybe if you say that you have experience, or in the programming courses before, okay, you can install a code block, and to run the exact same code here, okay, you can retype it, okay. So one is, I name it as hello1, you see here this hello1, and the other one is hello2. Okay, use the same code, create two projects, okay, just change the name of this line number 9, okay, and then you can run, okay, one after another, okay. So the results, okay, we show you, because the code here in line 10 and 11, it acquire the address of the variables a and d, okay. So what you will have here is, you will have the exactly same values, okay. Although the values that you may have is, it will not be the same here, but between these two, okay, the first program hello1, okay, here I write the hello1 here, but for the second program you can write down as hello2 here, okay, and you will get the exactly same address, okay. So this is basically the virtual memory of the program, okay. Okay, and then about the fifth point here, how can you find the process ID? Okay, I want you to think yourself, you can Google, okay, but to shortcut no the process, you can just open the task manager, okay, and in the task manager, okay, you can go into the details of the program, you can, okay, and then this is a column, okay. If you open the details of the program, it calls the PID, okay, this is a column of PID, okay, and then that is, it shows you the ID number of the process, okay. All right, this is the example, okay, where I use the code block to demonstrate the virtual memory, okay. Let's say if you look here, you can create no two projects here, okay. Just add a new project when you want to add a new project, okay. So if you see here, I use the exactly same code, okay. One is, I just put as number 1, okay. You can just put number 1, and then here you have the number 2, okay, same code, okay. You can copy from the slide, okay. So to demonstrate to you, okay, just let's activate the first project, okay. So you just run, okay. You see here, remember the number, just remember the, okay, the last two numbers is okay here. This is address for integer a 1c, okay, fe1c and fe110, okay. All right, so to activate the second project, you have to close this first. Okay, but just remember the values here, FE1C, FE110. Okay, so if you activate the second project, okay, and run it, okay, you see you got the exactly same address. Okay, this is this is the address within the virtual memory, okay, of this exactly no, same program. Okay, you see here that I have two different programs, but they have the same virtual addresses. Okay, okay, so but no, the address within the physical RAM memory, okay, you no, is with it would be different. Okay, and this is the composition of virtual memory of a program. Okay, so this is just a visualization of how basically the information, the data, okay, of a process ID of a program, okay, is being organized by within the virtual memory. Okay, okay, first in every process ID of a program, it contains first the text section. Okay, this is where the program instruction are located. Okay, so basically your source code lah, okay, is saved here, okay, within this stack, okay, or text section, sorry, here. Okay, and then you have sorry, here the text section here, okay, and then you have the second stack here. Okay, you have the initialized data. Okay, in the previous example, as I show you, I have two initialization. Okay, where I assigned the variable integer a, okay, into with the value of 12. Okay, whereas you can also store uninitialize, where you can just we call declare a variable. Okay, so if I don't declare a variable, it just store you the variables name or properties here, like integer b, without any assignment to any values. Okay, and then you have the stack section. Okay, this section allocate the data, okay, where the functions are called. Okay, for instance, if now if within your source code, okay, you have multiple function, okay, beside the main function. Okay, this function I think you have learned already in your previous programming courses. Okay, so whenever the variable are called, okay, the information is called within this section called the stack section. Okay, so basically when you exit the function, okay, then it remove the data. Okay, it's basically it's just temporary. Okay, you know that in the function, okay, if you remember, if you create a function like the the integer multiply, if you remember, okay, for example, and then you have the argument we call integer a and integer b, and then within here, and then sometimes you have another integer c, and so on in character. Okay, this is what we call, this is where this data, this information is now being saved, okay, within this section. Okay, so when the function is finished being called, okay, or the function exits, okay, it remove all this data. Okay, the fifth section is the heap section. This is for dynamic memory allocation. This is something that we will learn later. Okay, where you need the function called malloc, okay, to use the memory and the dynamic memory allocation. Okay, so and then when you want to unused, when you finish using the dynamic memory allocation, this this function, you have to memory it, okay, using the function free. Okay, okay, so this is just a model of a virtual memory. Okay, and for a virtual a model for a virtual memory, not really physical memory. Okay, just to visualize, to give a visualization about how basically the information, okay, of a program with the process ID is being organized within the virtual memory. Okay, going further, okay, this is again to demonstrate to you. Okay, let's say you have this code. Okay, how basically the information of this program, this is the code of your program, okay, is being saved, okay, within the virtual memory. Okay, so this is what we call the command line argument. Okay, so we will save here at the high address. Okay, it start from 000. If you remember, it will end for a 64-bit until the 8 times f lah. Okay, depending on no on the bit of your operating system. Okay, so, and then here you have first the text. This is the text of your program is being saved here, and then you have the initialization, okay, or declaration of your variable, okay. If you're integer a and double d, okay, this is with the assignment, with the initialized values. This is without the initialized value, okay. It will save here, okay. So the uninitialized, it will save here, okay. And then for the heap is basically for the dynamic memory allocation, where you use this function. Basically, you want to allocate the memory to the variable C. Okay, we have to use the pointers because it's part of the dynamic memory allocation. It will store here. Okay, and then when the stack heap is about when when you call the function. Okay, when the function run, this function display, it will use this memory section. Okay, when it's finished, or the program exit, the program display exit. Okay, the memory here will be freed. Okay. Okay, here we will talk about the heap memory section, or about the dynamic memory allocation. Okay, so in this our example, okay, we can use C, okay, for our example instead of C++. Okay, so we use to allocate or to manage the memory in C. Okay, you have three function. You have, remember, three function. Okay, one is the what we call the malloc. Okay, so in the malloc, okay, calloc, and to free. Free is basically to free the memory. I will explain to you what happens if you don't free the memory. Okay, in this example, okay, we want to allocate, okay, the memory based on how much you need. Okay, in this case is how much the user wants to basically to store the data. Okay, that's why it's when you use this approach, basically we can optimize the usage of the memory. Okay, so in this example, you can follow. First, what you need to have is the pointers. Okay, if you remember, when you declare, you just declare integer and then you give the variable's name. This is a normal that you have so far. Okay, but you can use these pointers. Okay, how to basically to use a pointers, you just add the star in front of the variable name, like in this example here, right? Okay, now we want to allocate basically the memory based on how many students in the class we ask the user. Okay, so we want to store the ID, basically the ID of the student. Okay, and we want to allocate memory about just about how much basically the student is within the class, in the class. Okay, so what you have to do is, okay, first you create the pointers here. Okay, and then we ask basically how much, okay, sorry, how many students in the class. Okay, so and then this is basically stored in a variable called number. This is normal variable, so now is being stored in the variables num. Okay, num. Okay, and then we want to allocate, okay, the memory for a variable called id. Okay, it's based on the values or the numbers. Okay, the basically the values of the integer num. Okay, what you have to do is, okay, first you have to basically use the function malloc. Okay, and malloc, and then we use the values in the variables num here. Okay, exactly the same thing here, all right? And then you just put the size of an inch, okay? And then we have to, we call to cast, okay? Because the num is integer, right? But the id is a pointer integer, okay? So you have to cast, okay? You have to convert basically, okay? In the easier, in more basically familiar term, you have to convert from integer into a pointer integer or integer pointer, okay? And you have to use the cast. I think you have learned this already in your previous programming class, okay? What you have to do here is you just put a bracket integer star. This is to indicate that all these values here, this is still integer. It will convert into a new type called integer pointer with integer star, okay? And then that's how basically you basically what we call allocate the dynamic memory to D, okay? We want to allocate the dynamic memory into the integer pointer ID, okay? How you do it? This within this line, this exact same line, okay? This is how you implement the dynamic memory allocation. And then of course then you can start, you know, uh, basically no, print out to show the values and so on lah. Okay, and okay, and lastly, when you use the dynamic memory allocation, okay, don't forget to free the memory. Okay, why? Because we want to avoid the memory leak. Okay, memory leak is basically it happens when you don't free the memory that you have used before exiting the program. Okay, what happened? You may ask what happened if the memory leak happened. Basically, it caused your program to be slower because there are some mismanagement in the physical memory of your program, okay, in your computer. Okay. Okay, now we will talk about the pointers. Okay. So to start is every variables that you use in your program, it contains two information. Okay, one is the what we call the values. Okay, some people call it content, but I prefer to call it values. Okay, or value. The other one is the address. Okay, so this for any variable, can be a character, b, or can be double f, okay, can be integer a, okay. It contains both value and address, okay. Remember that, that's the first thing, okay. So if I say that integer a equal to, okay, 1 to 7, okay, it contains the value of 1 to 7 here, okay, and also it contains the address, okay. This is the example. Let's say that the address of integer a is this value, okay. Okay, this is a normal variable, but for pointer, a pointer is a variable that contains the address of the data, okay. So if you cannot say that integer pointer a equal to a. No, it will cause the error, okay. It must contain the address of something. It can be a content address from another values, okay, for another variable, okay. In this example, integer pointer a, okay, we want to store the information. The values for pointers a is basically the address of the a, because we use, this is what we call the reference, okay. This is what we call the reference, okay, where we acquire the address of the integer a, okay. So in the pointer a, pointer still contain the address, okay, but the values, instead of a normal value, it contain the address value, okay. Since this pointer a, we assign the value with the, this value is the address of a, okay, so it will store the values for pointer a is the address of a, okay. All right, and then the size of pointer a for any type, okay, integer character is 4 byte. for for the 32-bit system. Okay. All right. I hope you understand. Okay, in the programming, okay, when we want to pass the data between function, okay, from main to another function, and then from this outside function into the main function, okay, or we call the return value, okay, we can use two approach basically. Okay, first is what we call is called by a pass by value. Okay, all right, this first pass by value. Okay, the second one is pass by reference. Okay, so what is the difference? Okay, the first one, this is what we call, this example is called by pass by value. Okay, and this is pass by references. Okay, you can try this code in yourself. This is two separate program. Okay, the first program, the second one. Okay, don't write. Okay, both of them under a single, okay, single source code, a single function, a single source code. Okay. Okay, when we use the pass by value, okay, basically we just pass a copy of the value, okay, example, to the function. Okay, so the function here doesn't know where basically this a here is being the address of of this integer a, okay, where it is located in the memory. It doesn't know. Okay, but if we use a pass by reference here, so it knows here both values and also the address. Now you have some idea about the advantages, okay, and this and also disadvantages between pass by value and pass by reference. Okay, whereas this is only value, this is address and value. Okay, so in this example, if you try to run this program, okay, so you just pass a copy of value of a, okay, into this function pass. Okay, whereas in this function pass you try to amend the value of a into 17. Okay, and then when you print out the value of a here, okay, it doesn't have any effect. It will shows you the value of a of 10 again. Okay, because when you pass the value, the function, yeah, the function cannot alter the values of the function. Okay, so here is just merely just merely call the function here. Okay, pass. Okay, so if we use the what we call the pass by reference, okay, it can alter, the function can alter the values of the variables, okay, because you give the information where basically the pointers is, the value is being located in the memory. Okay, you pass the address of the variable. So when you print out, it will show you the value of the altered value, which is 17. Okay, now I hope you know the difference between the pass by value and pass by reference. Okay, in the previous slide, okay, I showed you how to use pointer, okay, to basically to pass the value, okay, but you can also use a reference. Okay, you see the difference here. In the previous example, I use the pointers, okay, but here I use the reference only. Okay, so you can use that. Okay, basically in this example, okay, it shows you 10, okay, but also it shows you the output as 17. Okay, there are some alteration of this variable values of integer a. Okay, but you can use that. This is what I call the reference. Okay, the reference is contain the address of the value. Okay, you can use this method to initialize a reference. Okay, but what's the difference? Okay, now you may ask what's different. Okay, why to use pointers and why to use the reference? Okay, there are some limitation to reference. Okay, the reference cannot have a null value. Okay, and also it can only initialize to the one variables. Okay, why pointers can be point to any address. Okay, and we must initialize the reference that we have created. Okay, and pointers do not have to be initialized immediately. Okay, so in this within this context, okay, we know exactly that pointers has more advantages than the reference. Okay, so why bother using the reference where you have a more pointers that have more capabilities and more dynamics of using, okay, more flexibility. Okay, but I would say here I will stick to pointers. Okay, when you want to use it, when you want to decide whether reference or pointers. Okay, pointers has more advantages, but just for knowledge you must know and reference and also pointers. Okay, now it's about array versus the vector. Okay, in C we use array and C++ we use the vector. Okay, okay, a vector is basically just an alternative to the array. Okay, all right. To use a vector, you must include the vector library. Okay, don't forget that. Okay, vector is the difference between vector and array is you know that whenever you want to use array, first you must define the size when you initialize or you declare the array, whereas in vector you don't have to indicate um, any size that you want to use beforehand. Okay, so this is an example of the declaration of vector. Okay, so this is a vector with the type of integer. Okay, and then the one that is advantages of push vector is really flexible. Okay, just like whenever you want to add a value to a new value, okay, to the vector, you can just use the function what I call pushback. Okay, pushback here is basically to add the value. This is the value that you want to add. This is the I. Okay, you can get you can basically input any value that you want. Okay, here is just we make a loop cycle. We just store in the vector just a number of the loop, the iteration value 1, 2, 3, 4. Okay, but the here is the represents what values you want to add, the new value you want to add at the back of the vector. Okay, okay, so um, and then you also, when you want to relate the element of the vector, you can just use the function popback. Okay, what back means is you delete the last element of the vector. Okay, so I give example, I visualize it. Okay, first you add, now you initialize this, so the vector is contain nothing. Now you add, okay, the values of the element of, let's say here it has contain 5. Okay, so now you add for each iteration. Now the vector contain the value of 0, and then 1, 2, 3, and 4. Okay, at this point, at this line. Okay, now you want to get the size of the vector. Okay, you can get the size of vector. It basically shows you that it has the 5 element. Okay, and now when you use the pop back, then the value of 4 now is being deleted. Okay, then when you get the size of a new size of vector, now it shows you as 4. Now it's 5 element, now it's become 4 elements. Okay, so you can also initialize the vector like this, if you may. Okay, so basically you initialize it, but if you don't want to initialize, to give assign any initial values to the vector, you can use this way. Okay, this one, all right. So now I would say that no, a vector is more dynamic, is easier to use, is more what I call interactive to you, to the to the programmer to use, because the main point is you don't have to know when you design the program how much you want to allocate, okay, to the array or to the vector. Okay, that's the advantage, is a clear cut or explicit advantage of the vector. Okay, and you can try to run this code, try to type it and run it in your in your code block. Okay, here you can use the code block and run it as make a program as C++. You can visualize, okay, the dynamic, okay, the motion or the movement of the data in the vector is like a stack. Okay, okay, first we have the empty stack. Okay, when you use the push function, okay, so you basically you add, okay, the no the data into the vector. You use another push function. Now you will no goes into the last, no, into the on top of the previous value. Okay, so now it's become the first value, now it's second value. Whereas, okay, in the when you use the pop function, okay, so basically you delete the last values, which is number 2. Okay, so it's just remain with the value number 1 here. Okay, so and this is what we call this dynamic, we call the LIFO. Okay, last in first out. Okay, so the application of this LIFO stack is, first instance is like, for instance, you want to reverse a word. Okay, now you want to reverse, you get all the reverse from A B C, then you want to get the C B A. Okay, and also the compiler use no, this LIFO, basically this stack, okay, to use to convert the expression into prefix or postfix form. That's one. And also in browser, you can imagine, and you can see in the browser when you use the forward and also the backward, okay, button, okay, it goes to the previous site that you visited. Okay, okay, this is about the use of, string in C and C++. Okay, um, if you remember, okay, if you want to use string in C, okay, you have to use the array, okay, of the character, if you remember. Okay, this is in C. Okay, okay, so and now is in C++. Okay, you can use the string. Basically, you can just create a variable with the type of string without using the array. String is basically a collection of character in a vector. Basically, the string is using a vector. Okay, now the difference is, when you want to copy a string, okay, in C, okay, you cannot assign like in C++. In the string you can just put, okay, when you want to, okay, to copy the string name2 with the, values of name1, you can use the what I call this, equivalent value. Okay, name2 equal to name1. Okay, whereas in C it's not possible. Okay, you have to copy the whole array one by one. Okay, like in this line. Okay, right. So, and also the advantage of string is, since you use a vector as a base, okay, you can add character, okay, just using the function pushback. Okay, just like a normal array. Okay, now you know exactly, okay, the output. You can imagine what is the output from num1 and num2 here. Okay, so you can try to, to copy this code and try in your code block. Okay, and then we know what happened, what is the effect or consequence when you use a pushback, no, button for a string. Okay, and then interesting about C++, it allows what we call the function overloading. Okay, what is function overloading is basically, it means that you can create function, okay, in the same program. Okay, you can create the function, okay, that have the same name, okay, but a different argument. Okay, so now you have a different argument. This is for A, B, C, it use 3 argument. Okay, whereas for the second one it use only 2. Okay, for the third one, instead of integer, it use a double. All right, so it allows, okay, and how the program or the compiler decide is basically, it refers to um, what match the best, or not what match the most. Okay, every time the function is being called. Okay, so you can try to write no, this code here and run in your code block. Okay, for instance, the first call function here, okay, it gives you the two argument, two variables, 2 and 3, okay, and the compiler now will try to match, okay, within these three function that have the same name, okay, which basically switch, okay, this argument, this calling, okay, since not there are two variable, definitely it will call this function, okay. And let's last example, for instance, it use instead of integer, it use a double or floating values. Definitely the compiler will decide that this is the function that it meant, okay. Okay, so this is the no the function, what we call the function overloading, okay. So it's quite interesting, okay, but you have to really, be careful, okay, when you want to use this, this method, okay. Yeah, because important that no using when you want to initialize, this the function that you know exactly, okay, the management on how you want to organize or to use the argument or variables. Okay, and like variables, okay, you use pointers, okay, for a variable. You can also use pointers for a function, okay. The syntax or the way you use it is to, when you want to make a, a pointer function, okay, you use like this way, okay. So in this example, okay, likewise in the when you use a pointer, variable, okay, integer, character, whatever, okay. So now this void, the pointer function, ptr foo, is basically save the address of the function foo, okay, where is it's been defined here, because the void, the pointer function of ptr foo now must contain the address of a function, because it's a pointer function, okay. Whereas in pointer variable, it must contain the address of a variable, okay. The pointer function must contain the values or the address of a function. In this case, we choose the function, the address of the function foo, okay. Likewise, that you can alter, okay, the values in the what you call, in a variable, okay. For a pointer function, okay, you can basically change the code, okay, because function is just a memory allocation for codes, okay. So okay, both basically will basically function the same thing, okay, the same way, okay. So now you just declare, see here, you just no, you just give a definition of a function foo here, okay. And now the pointer foo will function like the function foo, the pointer ptr foo will match, will function like a function foo, okay, when you assign the address foo to it, okay. I hope you understand, if not, you can just try to copy paste or to write this code and try to use it in the code block. Okay, and then this is input output, no, a function to, a file input output, basically how you want to handle the values, okay, from a file or to a file, okay. In C++, we use a function or header file or library, what we call the f stream, okay. Basically, when you want to save the data to a file, like in Excel or txt or dat, okay. So to use that, okay, in C++ we use the f stream, okay, whereas in C we use the stdio, okay, standard input output, okay. To write or read a data to a file or from a file, okay, it can be only two type, okay. It's either the text or binary, okay. The how you can visualize that, let's say you want to install the okay, the values or the string, this value, a short integer of 768 and a character a, okay. If the basically if you want to read and write, okay, using a binary, okay, for a character A is definitely safe as binary as as A. Okay, A is, I think if you look into the ASCII table, there are some certain value represent the capital A. You can refer to the ASCII table. I don't remember, okay, what capital A represent, but you can Google it, okay. But in the binary file, okay, the 768 is basically safe as a number 768. Okay, so now you know that this value, this is the whole value. I don't know, 2 power of 0, 2 power of 1, 2 power, I don't know, up to 2 power of n or something. Okay, where you convert, okay, from base 2 number or binary value into the decimal number, it will give you the 768 value. Okay, whereas if you read and write as a text file, okay, it will show you as a character for each of them. Okay, first you will store A definitely as a capital, the ASCII table value of A, okay, of capital A, and then the character 8, okay, 1111 is represent as 8, okay, and then 6, and then 7, and so on. Okay, that's the difference between the binary file and the text file. Okay, this is the example of how you can write and read, okay, a data to and from a file, okay, in C++. Okay, what you have to do first is you have to use the f stream, since we are going to use some iteration. When you want to store the data, you have to include the vector. Okay, these two value you must include, remember. Okay, and then we say that the file name, okay, as a data.txt, right? Okay, and then you initialize some values. There are 3 values that you want to save in your file. Okay, uh, first you want to save the ID value, the CPA, and also the programming information. Okay, so now you have, this is the data that you want to save. Okay, this is the data that you want to save. Okay, it's basically 3 by 3. Okay, 3 by 3 data. Okay, so to write the data, okay, first you must, okay, you say that first you include the header file f stream, and then you specify the file name. Okay, and then to write your data to a file, okay, you just write down off stream, basically O stands for out. Okay, so this is your file, my out file. Okay, and then this is your file name here, basically this one and this one, exactly same thing. And then you can use the for loop to basically to install this value one by one. Okay, first is 0, 3.14 program BHM. Okay, sorry, this is not 3 by 3, this is 4 by 4. Okay, my mistake. So, and then you have 1, okay, ID1, and then you have the CPA 2.76, the program if BFF. Okay, when you finish, I mean saving all your data to a file, you must include this. Okay, remember, you must include to say that this is the end of your writing to a file. Okay, okay, so this is all about the write. Okay, how to read the file. This is all this line. Okay, this is to read the file. Okay, so first you must use the if stream. Okay, mine in file, this is just name. Okay, and which file you want to read, the file name, exactly the same thing here. Okay, and then you can, okay, again basically copy all the data from the file, okay, using this line. Okay, right, and then you use the for loop to print out, just to print out in the console, okay, all the values. And don't forget, here this example is forget to put that mark fe, this this code or this syntax is basically to indicate that this is the end of the reading from a file. Okay, in this example, is being forgotten to be included. Okay, but please, okay, try this in your code block. Okay, and try to play around. Okay, now basically in this example, the values are specified already, but just try to print about around, okay, using based on this coding. Okay, so that's the data now is being acquired from the user. The user key in what data to save to a file. You can try to play around that. Okay, okay, let's say you want to add new text and new data to a C++ text file. Okay, you just open and write the data. It will overwrite the new value, so your old data will be deleted permanently. You don't want that, right? So what you want to do now is you want to append the new value, okay, into your existing data in the file. Okay, so what you have to do is you just to use this syntax. Okay, sorry, you just use this syntax. All right, so then you can append your data. Okay, this indicate that you want to append a new value to the file. Okay, don't forget to close. Again, don't forget to close once you finish, okay, appending new values to your file. Okay, again, please try to write this code and play around it. Okay, other than text file, okay, before we just learn about C++ text file, you can also save as a binary value in your file. Okay, so in the text file, when you save as text, when you open that particular file, you can see the string, the values. Okay, if you save like 0, it will show you 0. Okay, and program bhm, you will see exactly this string, okay, in your file. Okay, whereas when you save as a binary, okay, when like in this example, okay, when you open that file, you will see this 0101 binary values. Okay, it doesn't show anything that you understand from the data unless you open the file, okay, in your program and print it out. Okay, then you see the what is value is basically being saved. Okay, that is the difference between the binary text file and the binary file and the text file. Okay, and this is the example how you can save your data, the same data that like the previous one. Okay, just that in this case you want to save as a binary value. Okay, what you have to do now is you specify, okay, this line. Okay, this is basically the f stream. Now before you have the o f stream, now you can just specify f stream. Okay, and then comma after the file name. Okay, iOS, you want this to be out. Okay, that means to a file out from your program. Okay, and then you want to save as a binary. Okay, so this advantage is that, and before that, okay, you must convert or casting all the data into character, because file typically is being used in the character type. Okay, so everything from integer, double, and also a string now will be converted into okay, casting into the character data type. Okay, this is what I call, this is the casting. Okay, and now you can save, okay, all the file. Okay, okay, to basically it's just basically it's really simplified when to write the file in form of binary compared to the text file where you have to use the loop and so on, like in the previous example. Okay, so likewise, okay, when you want to to read the file, okay, you use exactly the casting. Okay, exactly same syntax. Okay, this advantage is just like the simplification when you want to read and write. Okay, whereas the advantage of text file is you can basically you can see the values in the file. Okay, rather than just see 0101, this binary value. Okay, so again, please try this code in your when you have free time, okay, and then try to play around, okay, because it might be useful to you, okay, when you try to play around, okay, you can get familiar to the IDE, to the language, okay, so it's really useful to you. So thank you. Okay, that's all for the lecture today. So we will see each other again. Bye.